The moon, our celestial neighbor, beckons once more. Its silent, cratered surface has long been a source of wonder and mystery, inspiring countless generations to look up and dream of what lies beyond our own world. This time, our mission is not merely to visit, but to stay. We are embarking on a journey to establish a lasting human presence on the moon, transforming it from a distant, desolate rock into a new frontier for human exploration and habitation. Establishing a sustainable human presence on the moon is a dream long envisioned by scientists and dreamers alike. It is a vision that has driven decades of research, innovation, and collaboration across the globe. It represents the next giant leap in space exploration, a testament to human ingenuity and our insatiable thirst for knowledge. This endeavor is not just about reaching new heights, but about pushing the boundaries of what is possible. This essay delves into the framework of an unmanned lunar exploration mission, a crucial precursor to building our lunar home. These missions are the stepping stones that will pave the way for human settlers, providing the data and insights needed to ensure their survival and success. This mission will leverage cutting-edge technologies, including advanced artificial intelligence and sophisticated drone technology. These tools will allow us to explore the lunar surface with unprecedented precision and efficiency, uncovering its secrets and potential. Its primary objective is clear: to identify and assess potential sites for future human habitation on the moon. By analyzing the terrain, resources, and environmental conditions, we can determine the most suitable locations for building our lunar bases. This is not just about finding a place to land, it's about finding a place to live, to thrive, and to expand our understanding of the universe. The moon could become a hub for scientific research, technological innovation, and even a stepping stone for missions to Mars and beyond. The success of this endeavor hinges on a deep understanding of lunar geology, innovative engineering, and the seamless integration of human intelligence with artificial intelligence. By combining our strengths, we can overcome the challenges of living and working in such a harsh and unforgiving environment. The mission promises to be a groundbreaking endeavor, paving the way for a new era of lunar exploration and ultimately, human settlement beyond Earth. It is a bold and ambitious step towards a future where humanity is no longer confined to our home planet. This is a mission of immense significance, not just for the scientific community, but for all humankind. It represents a collective effort, bringing together the brightest minds and the most advanced technologies from around the world. It marks a pivotal step towards a future where humanity establishes a permanent presence beyond our home planet, ushering in a new era of space exploration and discovery. The moon is just the beginning. The universe awaits. The moon, though seemingly barren at first glance, holds hidden treasures beneath its surface, lava tubes, and subsurface voids. These naturally occurring formations offer potential sanctuary from the harsh lunar environment, making them prime candidates for human habitation.
Lava tubes, remnants of ancient volcanic activity, are tunnel-like structures that once channeled molten lava. These subterranean passages can extend for miles, offering vast sheltered spaces, shielded from radiation, micrometeoroids, and extreme temperature fluctuations. Subsurface voids and fractures, on the other hand, are cavities and cracks within the lunar crust. While potentially smaller than lava tubes, these formations still hold promise as potential habitats or research outposts. Their depth provides natural shielding, offering a stable and secure environment for human explorers.
Identifying and characterizing these subsurface formations is paramount to the mission's success. These hidden lunar oases offer the potential for long-term human habitation, shielding us from the moon's unforgiving environment while providing unique opportunities for scientific exploration. Understanding their size, shape, accessibility, and potential resources will be crucial in selecting the most suitable locations for future lunar settlements. These sites hold the key to unlocking a sustainable human presence on the moon, paving the way for a new era of scientific discovery and human exploration. Not all lunar hideaways are created equal. Each potential site on the moon offers unique advantages and challenges that must be carefully weighed. Selecting the ideal site for a lunar habitat demands meticulous evaluation and prioritization. Scientists and engineers must consider a multitude of factors to ensure the chosen location can support human life and scientific endeavors. Several factors come into play, each crucial to ensuring the safety and sustainability of future lunar inhabitants. These factors range from environmental conditions to resource availability and logistical feasibility.
Shelter potential reigns supreme. The chosen site must provide adequate protection from radiation, micrometeoroids, and extreme temperature variations. Without proper shielding, the harsh lunar environment could pose significant risks to human health and equipment. Lava tubes, with their thick walls and potential for sealing, are particularly appealing in this regard. These natural formations could offer ready-made protection, reducing the need for extensive construction. Resource availability is another critical factor. The Moon's surface holds a wealth of materials that could be harnessed for various purposes. The presence of water ice, for instance, would be invaluable, providing a source of water for consumption, oxygen for breathing, and even rocket fuel. This makes regions with confirmed ice deposits highly desirable. The location of potential resources will heavily influence site selection. Areas rich in minerals and other essential elements will be prioritized to support long-term habitation and scientific research. Location, location, location. Proximity to other lunar features of scientific interest, such as permanently shadowed craters or potential landing sites, would be highly advantageous. These areas could offer unique research opportunities and logistical benefits. Ease of access for both robotic missions and, eventually, human explorers is paramount. The terrain must be navigable, and the site should be reachable with current and future lunar transportation technologies. Logistical considerations also come into play. The site must be able to support the delivery and storage of supplies, equipment, and personnel. The terrain surrounding the site, the potential for future expansion, and the overall stability of the area all factor into the decision-making process. Flat plains may offer easier construction opportunities, while stable ground is essential for long-term habitation.
By carefully evaluating these criteria, the mission aims to identify the most promising sites for future lunar habitats. This involves a collaborative effort between scientists, engineers, and mission planners. This meticulous selection process will ensure the safety, sustainability, and scientific value of our future lunar outposts. Each chosen site will be a stepping stone towards a permanent human presence on the Moon. Laying the groundwork for a thriving human presence on the Moon, these habitats will serve as the foundation for future exploration and possibly even colonization of other celestial bodies. This is why you need constant high-speed communications. Before we dive into the phases of lunar exploration, it's crucial to understand the groundwork laid for seamless communication. Upgrading Baldy Hughes, British Columbia, Canada with high-strength transmission equipment, a geosynchronous Earth relay satellite, one equatorial orbit lunar relay satellite, and one polar orbit lunar relay satellite ensures near 365 24/7 constant high-speed communications. The mission to identify and assess potential lunar habitation sites unfolds in a series of carefully orchestrated phases. These phases are designed to systematically gather and analyze data, ensuring that every step taken is informed by the latest scientific insights and technological advancements. Each phase builds upon the last, culminating in a comprehensive understanding of the lunar subsurface and the selection of prime locations for future human outposts. This methodical approach not only maximizes the efficiency of the mission, but also minimizes risks associated with establishing a human presence on the Moon.
Phase 0. Groundwork for communication. Before any exploration can begin, establishing a robust communication network is essential. This involves upgrading transmission equipment and deploying relay satellites to ensure constant high-speed communication between Earth and the Moon. Phase 1. Remote reconnaissance. This initial phase utilizes orbital spacecraft equipped with advanced sensors to survey the lunar surface. High-resolution cameras capture detailed images, searching for surface features that may indicate the presence of lava tubes or subsurface voids. These features are crucial as they could provide natural shelters for future lunar habitats, protecting inhabitants from harsh surface conditions. Ground-penetrating radar probes beneath the surface, mapping the lunar subsurface and identifying potential cavities. This technology allows scientists to see beneath the Moon's surface, revealing hidden structures that could be ideal for habitation or resource extraction. Phase 2. In situ exploration. Once promising sites are identified, it's time for a closer look. This phase is critical as it involves direct interaction with the lunar environment, providing data that remote sensing cannot. This phase deploys autonomous drones to the lunar surface. These advanced robots, equipped with a suite of scientific instruments, venture into the depths of lava tubes and subsurface voids. Their mission is to gather detailed information that will be crucial for the next steps of the mission. They collect detailed three-dimensional maps, analyze the composition of the rock and soil, and search for signs of water ice or other valuable resources. Water ice, in particular, is a key resource as it can be used for drinking water, oxygen production, and even fuel.
Phase 3. Data analysis. The data gathered by the drones is beamed back to Earth, where it undergoes rigorous analysis. Scientists and engineers meticulously study the three-dimensional maps, compositional data, and other findings to assess the suitability of each site for human habitation. This phase is where the raw data is transformed into actionable insights. They create detailed models and simulations to evaluate structural integrity, resource potential, and overall habitability. These simulations help in understanding how future lunar habitats can be constructed and maintained, ensuring the safety and sustainability of human life on the Moon. This phased approach ensures a systematic and comprehensive exploration of the lunar subsurface. By breaking down the mission into manageable phases, each with specific objectives and methodologies, the mission can adapt to new findings and challenges as they arise. By combining remote reconnaissance with in-situ exploration and sophisticated data analysis, the mission aims to paint a clear picture of the lunar underground, paving the way for informed decisions about where to build our future lunar home. This integrated approach not only enhances our understanding of the Moon, but also sets the stage for the next giant leap in human space exploration.